and under division we have, remember that we talked about this word before, it's an algorithm,
Yeah.
which means the way that we do something. Algorithm. And with division, what is our algorithm? You guys had a different one than I had. You did something like goes into gums. I'm still gonna go with mine here, and it's divide, multiply, subtract, bring down. I can't remember what bring down. I don't remember what we said. Did my sister break down? I don't know. Does man see bomb? Whatever it is, you follow that same pattern. And the deal is, what's different from what we already did is that you're going to have to do it more than once. And a lot of this depends on how good you are at your division there. Let's do 9 into 375. And some things that I'm going to tell you, you need to be very, very careful about. Okay? And this is kind of the gist here. Okay, we're dividing 9 into 375. And you start at the left and you look, and go to the right here. If 9 doesn't go into 3, which it doesn't, okay, you should not put a number above the 3. Okay, you don't put a number above the 3 unless 9 goes into it. I'm going to put a little X there just to make sure I do that. And then I go to the next number and say, does 9 go into 37? That is my goes into part that you called it. I call it the division part. You know, how many times does 9 go into 37, or 9 times what gets you close to but not over 37? Abram? Well, it goes more than that. See, here's the deal. If you do 3, you get 27. And then when you do that's your multiplying part. Then when you do your subtracting part, you end up with 10. Here is where you'd have to stop and say, uh-oh, I did something wrong, because when you subtract, this answer cannot be bigger than your goes into number. Because if it is bigger, that means you could have gone another time into it. So 3 is not right. So I need to back myself up here. And say 9 goes into 37 how many times?
4.
4 times. And then I do my multiplying, which is 36. My subtracting. I've done my divide, my multiplying, subtracting. I get a 1. And that's good because it's less than my dividing number. And then I bring down number. And I need to see this, children, okay, for at least the next couple years. When you bring a number down, I want to see the arrow of the number that you're bringing down. You bring 5 down to here. And then the whole pattern, after you bring that number down, the whole thing starts all over again using this number instead of this top number. How many times does 9 go into 15? 1 time. Multiply 1 times 9. Subtract. You get 6. And again, it's good to get 6 because it's less than the number you're going into. When you have no more numbers to bring down, and I know that because I have an arrow after that last number, this leftover is our remainder number. So it's 41 remainder 6. 41 remainder 6. Now let's do another one. What about 5 into 645? 5 into 600. 5 into 645. Following my same divide, multiply, subtract, bring down pattern. What's the first thing I do?
Divide.
And what am I dividing? What and what, Parker?
5 and...
Does 5 go into 6?
No.
Yes,
Yes.
it does. How many times? So that'll go right above the 6, because that's the one that's you're doing dividing. I multiply 1 times 5. I subtract. I bring down. I check to make sure this answer is less than my dividing thing. And then my next step is to
Bring down.
write the arrow and bring it down. Start the whole process again. Does 5 go into 14, Amelia?
Yes.
How many times?
2 times.
2 times, because 5 times 2 is 10. I subtract. Is 10 a good number? Yes, because 4 is less than 5. And then I bring down again. How many times does 5 go into 45?
9 times.
9 times. 9 times 5 is 45. I subtract. I get nothing left, and that's good, so there's no remainder, and this would be the answer. And then we have to do one more example, and that one is what happens when it's in money. 7 into $3.64. 7 into $3.64. One thing that you should think about, kids, is money is one of those things where you can't have remainders in. Okay, there's no such thing as a remainder $5 or cents or any of that. So when they give you a dollar problem, you're probably not going to get a remainder. So when you do all of this, you're not going to have anything left over that gets put with the letter R. And with dollars, when you're dividing something, when you're dividing dollars by something, your answer needs to be in dollars. So what I would do as a first step is, wherever this little decimal is here, go straight up and put a little decimal there, because there's going to be a decimal, a cent in your answer there. And then you just start doing it the same way. Once you do that, you can ignore everything else. Okay, you do it in like a normal problem. I mean, you can put your little dollar sign here if you want. Does 7 go into 3? No. And it's acceptable to put a 0 above there because we do have $0. Okay. Does 7 go into 36?
Yes.
How many times?
5.
Okay, 5 times. I do my multiplying. 5 times 7 is 35. I do my subtracting. Can I have 1? Yes, because it's smaller than 7. And then I bring down. How many times does 7 go into 14? 2 times. And that's good because with dollars I should never have a remainder. The answer is 52 cents. $0.52. One more for you to try. How about this? 4 into $4.56. I'll let you give this a roll by yourself. $4.56. Divide that out for me. You have $4.56 and you're split it among 4 people. How much should each person get? Should work out evenly, as fate would have it. Let's see what we got here. If it's dollars, the first thing I strongly recommend you do is, so you don't forget at the end, bring up your decimal right exactly straight above where it's at. Put a dollar sign here so you don't forget to label it. Does 4 go into 4?
Yes.
Yeah, 1 time. Multiply. Subtract. Bring down. 4 goes into 5.
1 time.
1 time. Multiply. Subtract. Good answer. Bring down. Again, make sure you're showing me these arrows. I need to see those. 4 times what is 16? 4. You get nothing left over, and there's your answer. $1. 14 cents.